Okay, so let's start with the neural network. We are going to study basic neural network, and the programming of this will be bit difficult, or not bit difficult, but you must understand the basics programming. And thank you all for joining this session one more time, right? So for neural network, let me import basic numpy libraries as np, and then I'm going to have this input underscore data is equal to np dot array, and then I'm going to import 2 comma 3, right? So this is my input point here, right? So this is the neural network point, right? So when you go back to the neural part here, like what is the neural network exactly, how it looks like. Suppose this is the first neuron and this is the second neuron, and we are going to mimic human brain in the neural network, right? So this is the second step. Like suppose we have the second step over here, and then we have the second step over here, right? And then we have final neuron over here, which would be the output of my entire network, right? Along with this, I'll have the network towards this side, the network towards this side, right? And also I'll have this direction, this connection to this node, this direction to this node. So this will be like fully connected network, I would call it, right? And then the second neuron will connect to the final output, and the fourth neuron will also connect it to the final output, right? Here we have final output, which means we can have two classes, right? Either it can go for 0 or 1, true or false, male, female. So for binary classes, your output should be 1. All right. So in this code, in this neural network code, I have given two values, right? What are these values? These are 2 and 3. So at the initial point, I'll give 2 and 3 here, right? Now I'm going to assign some weights also, right? So what's weights here? So for weights, I'll create some dictionary. So we know for the dictionary what are the like notation. For first we have round like curly braces, and then we have node underscore 0, and this will have like np dot array, and inside this np dot array I'm going to store 1 comma 1. So what is exactly I'm going to illustrate in a few seconds. Let me define my weights, right? So along with this, I'll have another weight. This will, I'll call it 1, and I'll have another weight. So for this, I'll call it output, right? So how these outputs are, like for this second part, I'll take -1 comma 1, and then I'll have 2 comma -1, right? So how it look like, right? So let me run this part, run this code. So start from the right hand side. So output is 2 comma 1. So for my output part, you can see this weight. So along with each edge, each arrow, each diagonal part, I'll have some weightage associated. So here we have 2 on this weight. It's totally depending upon you what kind of weights you are tuning, right? But as of now, we are assuming this is 2 and this is -1, right? Come back here. Node 0 is having 1 comma 1, right? Which means for this first point, right? This one, right? So this is 1, and for this point I'm having 1 also, right? When I go for the -1 and 1, so this would be like, let me change the color here. This would be -1. The weight of this point is -1, and weight for this part would be 1. Can you see? This is -1 and this is 1, right? Now, once we have assigned the respective weights, let me assign variable for the respective nodes. Let's say this is x here, this is y, and let me take it g over here. Why? Because we are going to calculate x here, we are going to calculate y here, we are going to calculate z here, right? Now, x would be, when you go for the graph or the directed graph, you will calculate manually. This x would be something like like this one. Neural network says summation of xi multiplication of wi. I is equal to 1 to n. What does it mean? It means we are having xi means input. From the left hand side we are getting these inputs. Wi means associated weights. So we are going to multiply each weights, and this final value will be x1 w1 plus x2 w2, and till there we will have number of neurons and so on, right? Now go back to the x value here. The x will be 2 into 1. You can see 2 into 1, and then from here we have 3 into 1. Can you see? So this would be 3 into 1. The final value would be 5. Alright. Now go back to the y value. When I check the y inputs, so from here I am getting 2 into -1, that would be -2, plus 3 into 1 would be 3. So I would be getting 1 at this point, at this level, at this milestone. I'll getting 1. Is it clear to everyone? This is the mathematical and very pure or very simple mathematical we are going to dealing. And if you will understand each step by step, you will get everything very clearly, right? So is there anything I need to explain? Okay, so we will discuss the value of z. So till x we have obtained 5, and 5 will multiply with 2, and then -1 here, y will have 1 value, this 1 will have -1. So we have 5 to the 10 -1, and is equal to 9. So finally, we are getting 9 as an output of this entire network. This is single iteration, and how Python is going to calculate this one. Let me go back here, go back to the Python code. So we have weights already defined by us, respective edges 1, 1. You can see 1, 1 for the first input. For the second node, -1, -1, -1, 1. You can see for the output 2, -1, 2, here we have 2, here we have -1, right? So we have assigned respective weights, we have assigned the inputs. Now for these inputs, we are going to calculate node _0 _ value, right? And then we have input _data, which is actually 2, 3, and this would be multiplied by weights, my weights, respective weights. And for this weights, I'll take the first node _0, right? So this will take only 0. What is 0? 1, 1, right? So I'm going to sum the entire value, which is the product, and then sum value, right? So let me run this code here, and when I run this code in either part, you will get the 5 value, and this 5 is nothing. Here you can see this is x value. We are going stepwise step. Otherwise, if you'll directly jump to the higher very complex coding, you won't understand the iteration there. So we are having very small tiny steps, how we are getting this 5, how we are getting this 1, how we are getting 9. अगर आपने इसको समझ लिया, इन स्टेप्स को समझ लिया, इस कोड को समझ लिया, 100% you can understand complex coding also and how neural networks are working there. You will understand activation functions also, you will understand the iteration, epochs, everything you will get very easily, right? Now go back to there. The second part of this coding says we need this one minus this one here, right? So I'm going to change this node 1 value within the node 1 respectively, and for this I'm going to create copy and change the value node 0 with 1, and let me run this code. So this input data is 2 comma 3, which is constant for us. Node 1 is -1 1, we have set at our choice. We have calculated the second output, which is 1 here, and you can see the programming is also giving 1 here, right? Now this is called hidden layer, right? Yes.
Sorry for interrupting.
No issue.
Actually,
It means pixel values here, right? So in the higher cases, like suppose you have go for the like CNN, when you go for the CNN in AI, so in CNN you will find the images, and then you can see the can you see these images, this bird, how tiny level they are extracting this single pixel value. So this single pixel value is going to converge in convolutional layer, right? So we will discuss this convolution pooling, everything there, right? Can you see this input level for this entire 2? But can you see this small box there? 2k scattered pixels bhi hai, but along with these pixels they are taking 1 pixel at a time, and 1 pixel value will range from 0 to 255 if you are working on grayscale level. If you are working on RGB, so it will have 3 channel, but for grayscale we have only 1 channel, and the value is ranging 0 to 255. Now we are considering not the 0 to 255 values, we are considering here only 2 pixels. So I am considering only 2 pixels which is having values 2 and 3 only, which is the constant value here. Did you get this point now? If you get,
yeah, got it.
Now I am going to calculate for my hidden layer. So for this hidden layer values, I am going to calculate mp.array, and then inside this array I am going to calculate node underscore 0 value, which is the first out, and then I am going to pass the second neuron output, right? So what's the value of node 01, which is 5? I am going to pass 5 here. What's the second output of this network, which is y, which is actually 1? So I am having node 1 value here, so this is going to pass 1 here, right? And then I'm going to pass print this one hidden underscore layer values, and just run. You can find 5 comma 1, so which is just x and y both, right? Now along with this 5 comma 1, we are interested in the output value, final output. So for this final output we are going to take hidden layers output, right? So hidden layer would be multiply with WEIGST weights, and weights will have final output, right? So along with this output we are going to sum the same operation we are pursuing here, which we did here for node 01, right? and instead of node 1 we are taking these 2 comma minus 1 for these outputs, 2 and minus 1. Now if you are going to print this output simultaneously in the next line, it will give 9. Can you see this 9? Right? Now you understand how this 9 is getting output, because we know mathematically this neural network is computing using this formula, and finally we are getting 9. If you go directly for this coding, can you understand how can you get this 9 over here? Of course no, right? So that's very difficult to find out how we are getting 9 over here. So we just go for the entire value here, right? So when I go for any other further question query, actually it's a very simple neural network, right? Here we are not using any activation function, not threshold value, not any optimization, nothing. Very simple neural network, right? It says if the value is less than 10, you just consider this image is belonging to cat. If the value is greater than 10, so this image is belonging to dog. This is the meaning of this output. This is how probability working there, right?
So we are classifying, right?
Yes, this is
Oh, okay.
classification problem, and you just set the
Oh, okay. That.
threshold value for the probability value or the particular value, and then assign this cat and dog. So this is the very broad definition, not the exact precision value, but this also can be supervision for different output, right? We are going to classify cat and dog, male and female, eyes, sound quality also. Actually neural network or CNN is used for so many things, right? This can be used for audio data set, right? We can use like we are failed with machine learning algorithm because we are not having very pixel wise pixel, because what are the two dimension problem? The two dimension is having very large data set, right? And we have so many pixels there, right? So each pixels are going to flatten, and then we are passing this to the neurons, right? Now for the audio data, for the video data, right? For the image data set, we have so many values, right? Why so many values? Because they are working pixel by pixel, right? So this audio, you can go for the one dimensional CS convolutional network. For video, you can go for image, you can go for two dimensional image data set. For video, you will have to go for three dimensional data set, right? Because we have frames of images. In video, we have number of frames in images, right? Video is nothing but so many images are running within fraction of seconds, right? Like suppose if I go for the YouTube video and like create video using frames, right? So you can see there is like cartoon video, let's say initially how cartoon frame animation, I think that's not given here. So this is what this is. Actually they are playing the same this one, same frames number of times. Can you see? Single frames is run number of times. They are scanning the frames and they are framing number of times. Within a fraction of seconds, they have so many frames, changing frames rapidly, so that our eyes are thinking that they are repeating this one, right? If you have this video, This is something. Example, we are going to cover something using definition, right? So inside the definition, we are going to predict with network. This is, I'm going to create my entire network and I'm going to pass my input underscore data, right? And then I'm going to calculate node 0 in the first hidden layer, right? So what I'll do, I'll write node. Okay, so first let me
Hello,
assign.
sir.
Yeah, please.
Can you give an example?
We are going to use activation function in this function itself. So first assign me to input data. This input data is np dot array, and inside this np dot array I'm going to assign 3 comma 5. So instead of 2 comma 3, now I'm having input data 3 comma 5, right? So how this neural network will look like? We have, create this one. We have first two inputs. So these inputs are passed with two constant or some this one means scalar values. These are 3 and 5 respectively. All right. Now I'm going to set respective weights for this one. So let me copy this weight so that I don't have to copy means type job. So for this, I'm going to take node 0. This is 2 comma 4, right? For node 0 underscore 1, I'm having 4 comma minus 5, right? For the another input, cut C, and then having cut V, if I can hit enter, so you can see this is comma, and then for this is called node 0 1, and then I'm having 1 underscore 0. So this is value 0 comma 1, and then I'm having the next value node 1 1 1 underscore 1, and this is having weights of 1 comma 1. All right. So finally we have output as, this would be quotes, and output as 7 here, right? And then run the code. Do we have any other option? I think something. No, this is the mismatch code. Do we have any other mismatch code? No, 0. All right. So when you are going to print this weights, so we have respective weights also, right? So for this weights, we are having this values, right? Now, how this neural network is going to complete here? So we have the second layer over here, hidden layers. This is the input layer. Now we have two layers here, and the finally output layer, right? Where is the toolbar? It has gone. Okay, so let me create using the single color itself. So here we have this inputs and this inputs, right? So what's the first input? We have 2 comma 4, right? So we have, okay, that's it. So we have, this is 2 and this is 4, right? Then we have second input from this side and from this to this one. Now what are these? 4 and minus 5. So this is 4 and this is minus 5, right? I just created the wrong bits. This is 2 and this is 4, and this is 4 and this is minus 5, right? 4 and minus 5. Is this correct? All agree? Now we have this input and this input. What are the respective weights? 0 comma 1. So here we have 0 and 1, right? Then we have 1 comma 1. Of course, here we have this one and this one, and this is 1 and this is 1. Now we have the final output layer, which is saying 2 comma 7. So of course this would be 2 and this would be 7, right? Now at each layer they have applied ReLU activation function, right? So what is the means rectification linear inputs, right? Rectified linear inputs, right? So when you go for the ReLU in CNN or the neural network, you can see the output are just reverse, right? Whenever you will find negative value, it will give 0. Whenever you have positive value, it will give the same output. It just convert the negative value into the 0, means it doesn't allow any negative value because pixel values are not negative anyhow. They are ranging from 0 to 255. Therefore, but your calculation giving somewhere we will find negative value also. So in order to deploy ReLU activation function, we will convert all the negative value in it into the 0. So this is the hidden layer using weights which are preloaded in our value. So when you go for the this one negative part like functionality, you can see here we have functionality part or equation wise. On the right hand side, you can see every negative value is just tuned to 0 and rest are as it is, all equivalent to they are not having any changes, but for all negative we have maximum 0 to z. All right, now inside this function we are going to calculate all these layer by layer. So for this I'm going to calculate 0, and then first we are going to calculate input, and then input is equal to this one, and then input underscore data multiplication weights, which is the actually we are doing from the very starting, and then node underscore 0 0, which is the first part, first hidden layer, and then some value and this one, right? We are deploying whatever the output of this node, right? So let me write this code in outside my this one, outside my layer, right? And let me let me print this first, right? Can you see it's giving 26, right? How it's giving 26? Let me go for my entire network, right? We have, let's say this is value A, this is value B, this is value C, and here we have value D, and here we have, let's say, value E. All right, so now calculate A, B, C, D one by one. So what would be A? Very quickly, anyone, any idea what would the value of A? So 3 2s are 6 plus 5 4s are 20. Can you see this one? This is straightforward calculation. This is 26. So we are getting 26 over here, right? When we go for the second, similarly, if you go for the, but we are going to deploy some ReLU function here, right? Node 0. Now let's say, let me calculate B over here. What would be the B here? For this B, we'll have 4 3s are 12 plus 5 5s are 25. So this would be value equivalent to minus 30, right? But when you will apply ReLU over minus 30, ReLU activation function, so this value will be equivalent to 0. This is the my calculation. Means theoretical one. Let's go back to the coding part, right? For this entire statement, let me add some one, and let me add this one. Here I'll call it 0 1 input, and for this I'll deploy 0 1 sum, and then finally I'll try to print this value, right? You can see this is giving minus 30, right? So what about the ReLU function, right? When you deploy this ReLU function there, so you will have to define this ReLU somewhere, right? So we are going to define ReLU, right? So inside this ReLU, whatever the input we will provide, this input will go inside the function, and we will give output is equal to maximum of 0 comma input, right? So this would be the output, and finally we are going to return output, right? This is the functionality of my ReLU, and this is what we have seen in this equation. And in this equation, ReLU is maximum 0 comma g, right? So let me call this ReLU here. If you call this ReLU minus 13 and try to print, so you will get 0. Can you see? This is getting output 0 because we have set in such a way. When we are getting any value apart from negative, so we will give, let's say, 53. So we are getting 53, which means our ReLU activation function is perfectly defined as per its nature, right? Now this is the responsibility at each layer we will be covering here. So let me copy the entire code, but C, and here we have entire code. Did you get this entire code? But अभी देखने में ये बहुत लग रहा है, but if you understand step by step, you will understand how we are doing there. Did you get all these steps, everyone? I want to listen from everyone's side.
Yes, got it.
13 over there, right? Now I am applying my ReLU function over this node 0 1 input, right? And finally I am going to cut C. Let me drop me down before the definition. Now it's recognizing this definition, and then I'm going to copy this one. Can you see the output of this one? When I'm applying this ReLU function over node 0 1 input, it just changed to 0. But previously the same variable was producing minus 13. Now the objective of this line is to convert to deploy ReLU activation function at the node level. Can you see? Now this code is deploying at this level. ReLU is deployed at this node level, right? Finally we are getting this as 0. The same thing I am repeating so many times for each node. Can you see ReLU over here, ReLU deployed here, ReLU deployed here, output here, right? What is the hidden 0? We are hidden 0 will be 26 comma 0, right? So let me calculate C and D also, right? Anyone can tell me the value of C and D now? Any idea what will be the value of C and D? So in this level we have C is 0. Here we will have 0, right? And then here we are obtaining from the lower part 0 into 0 would be 0. Is this correct? We will get 0 output. Why we are getting 0 here? Because we have deployed ReLU function from the previous layer. इस नोड पर ReLU फंक्शन लग चुका है at B level दोनों पे ही. This is the reason this will pass 0. Otherwise, if you do not deploy this ReLU activation function, it will pass minus 13. So the value would be might have my 0 minus 13, C would be minus 13, right? But once you have deployed 0, so value of B is 0 here, right? So value of A is 26. So 26 multiply 0 is 0. 0 plus 0 is 0. Did you get this thing? Now go back to the D. Anyone having any idea? Please raise your hand or poke me up. Like I am not getting this point, because now we are going to calculate this D point here. This D is 0 into 1 and 26 into 1, right? So 0 into 1 would be 0, plus from this S, here you can see 26 into 1 would be 26 into 1 would be 26. Did I correct the answer? So D would be finally 26, right? The same you will get output from this one, right? Now, if I am going to call this entire function for my output variable, and this output variable call this definition product, this one, and let me copy these entire phrases here. So this is the calling, this is calling my function, user defined function, and this is having input data. What is input data here? Input data is 3, 5. So from the scratch it is going to pass 3, 5, and we are going to pass this 3, 5, right? Okay, we didn't run this code. Now successfully we have run this code. Now we are getting output. Now we are getting output also. Now, oh, typo mistake, we are getting 182. Now go back to the how we are getting 182, because we are getting C is equal to 0. 2 into 0 would be 0, plus 26 into 7 would be how much? 26 into
182.
yes, 26 multiply 7, dot C all dot B, we have 182, right? So let me write over here first and foremost. So finally we are getting 182, and then we are getting the value of E here 182. Do my code is giving 182? That's perfectly fine. This definition is also giving 182. This is how entire network, entire neural network within the hidden layer performs. This is how when you go for the like image pixel in CNN, when you search for any CNN value, when go for the images, and if you go for this window size, this will be very scary part, right? This will be again very strong mathematical background, right? This is again very strong mathematical background. If you will directly jump into such kind of images, अगर आप इन images को आप देख लोगे तो आप सच में घबरा जाओगे. You will be scary, like how they are treating, how they are converting, right? So what's the difference between this image and the image we have discussed here, right? So what's the difference between CNN versus, which is convolutional network, versus neural network? Anyone? Any idea? But any idea? I am giving few seconds. Let me check few questions. Do we have any question? What is the difference between CNN and neural network?
I think CNN has more number of layers.
Yes. When you have CNN, which means you are covering so many numbers, right? But when you are talking about neural network, which we have discussed right now, which is just only this part. Okay. So this is only neural network, but when you emphasize over CNN, we have others layers also, like other pre-processing part. Here we have convolutional layer, we have pooling layer. So pooling is agar max pooling, average pooling. Here we have like activation functions at each layer. Here we have kernels also. So that's the advanced part, but for the technical terms, you just understand we have pre-processing for entire matrix. What is the matrix all about? Each image is nothing but matrix itself, right? Raw input is matrix, and these metrics are nothing but pixels values in between 0 to 255, right? And these pixels are nothing but positive numbers or scalar values. तो उन स्केलर वैल्यूज का जो मैट्रिक्स है उनको हम यहाँ पे डील कर रहे हैं, एंड फाइनली वी आर गोइंग टू दिस पार्ट, राइट? टिल दी रीचिंग विद माय न्यूरॉन्स, which is our first layer. You can see this is our first input layer. We have so many pre-processing in CNN, but in the neural network directly we are getting this one. But question arises, where is the question? How we are getting this part? This is very neurons. How we are getting this one? What we do, can you see this image? Suppose you have final input after all the processing in CNN. Suppose you have 7, 9, 17 and 19. This is your final output. Of course, this is very not easy output, but if you are something, so you just apply flatten layer. This is called flatten layer. You can see this is flatten layer. What is the responsibility of this flatten layer? It just convert entire layer into the vertical position. 7, 9, 17 and 19. Now our neural network starts here. This is our one neuron. This is the first input. This is our second neuron, second input. This is our third neuron, third input. This is our four neuron, four inputs. Like as we have seen here, we have only two neurons, two inputs. Of course, you will have four neurons, four inputs. Accordingly, you will set the hidden layers. It will convert the like connections there, and it will deploy further activation part and further classification, whether it is cat or dog, whether it is the image of cancer patient or not cancer patient, any tumor or non-tumor image. Did you get this point? How these pixel wise pixels we are treating?
Yes.
Each one of you, if any image is of size 512 cross 512, what would, how many neurons will be there in my neural network? This is the neural network. This is not the CNN. Here we have entire structure is called CNN, but till here we have only CNN. So how many neurons will be there at input layer? This is my question to everyone. What is the input size? I'm not talking about hidden layer size, not talking about output layers. Of course, if the output is binary, so you will have one output that will give 0 and 1 respectively. But my question is, first and foremost, how would you set up your input layers? What would be the number of these neurons? Tick, 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 and this one. What would be the number of neurons at the input layers? Anyone?
Equal to the number of pixels in the image.
Huh?
Number of neurons in the input layer is
512 multiply 512. Is it your answer? Yes. This would be number of neurons for my values. right? These number of neurons, right? But we cannot go for these number of neurons. This is the reason we reduce size of these image by convolutional layer, by flattened layer. Everything we will discuss in upcoming session, but as of now you can understand this is the difference between CNN and neural network only. So neural network is the part of convolutional neural network, the name itself illustrating, right? And how neural network are treating, we have this fundamental part, right?